Good day to each and everyone. Today, we will be going to discuss a new topic entitled Anova. But before we formally start to our discussion, I am going to introduce to you the presenter of Group 5 from BS Biology AB13. Let me start with myself first. As a group leader, I am going to discuss the introduction and the learning objectives. So here are the members of the presenter. We have Amado Joanna, which she will be the one to discuss the formula of ANOVA and the types of ANOVA. Second presenter is we have Melo Beverly, which she will be the one to discuss on how to use the ANOVA method. Third presenter is we have Pirote Francis Paul, which he'll be the one to discuss on how to get the results of ANOVA using the JAWS or the Excel. Last but not the least is we have Freya Delecana, as she will be going to discuss on where it usually used and how it is useful and important in the field of biostatistics. So before we formally start with our discussion, let me introduce to you the learning objectives. Upon successful completion of this lesson, you'll be able to understand the definition of an ANOVA, learn and know the formula of ANOVA, to differentiate between one-way and two-way of process methods of an ANOVA, on how to solve problems using an ANOVA formulation and method, learning and understanding where it usually applies, and know and understand its importance and role in the field of biostatistics. Let's define ANOVA. First, what is an ANOVA? ANOVA, which stands for Analysis of Variance, is a statistical test used to analyze the difference between the means of more than two groups. This tool is used to segregate and observe mean variability inside a dataset. It has mainly the two groups, which is the systematic factors and the random factors.
The formula for ANOVA is F equals MSE divided by MST, where F equals ANOVA coefficient, MST equals mean sum of squares due to treatment, MS equals mean sum of squares due to error. One-way ANOVA. Let us look into one-way ANOVA formula. F equals statistic or F ratio. F equals MSB divided by MSW. In this formula, F equals coefficient of ANOVA, MSB equals mean sum of squares between the groups, MSW equals mean sum of squares within groups. One-way ANOVA analysis of variance is commonly called a one-factor test in relation to the dependent subject and independent variable. A statistician utilizes it while comparing the means of group independent or of each other using the analysis of variance coefficient formula. Two-way ANOVA. The prerequisite for conducting a two-way ANOVA test is the presence of two independent variables. One can perform it in two ways. Two-way ANOVA with replication or repeated measures analysis of variance is done when the two independent groups, dependent variables, do different tasks. Two-way ANOVA sans replication is done when one has a single group that they have to double test like one test. Moreover, one must meet the following condition for its application. First is the population should be near normal distribution. Second is the sample should be independent. Third is the variances of the population have to be equal. And lastly is there should be an equal size sample in the group. There are four assumptions that must met before using two-way ANOVA. First is the normality. Observation from the sample population are normally distributed. Second is the sample size. The number of observation must be the same for each group. Third is the equal variances. The variances for each group are equal. And lastly is the independence. which is the observation in each group are independent.
So for you to not be able to confuse, let's just remember that one-way ANOVA is used when you want to test two groups to see if there's a difference between them. And one-way ANOVA has only one independent variable with two levels. When it comes also to two-way ANOVA, it is used when you have one group and you're double testing that the same group. And it has two independent variables where it can have multiple levels.
So in this video, I'm going to show you how to perform and get the result of ANOVA using Microsoft Excel. So as you can see here, I have data from three different groups for their performance on the vertical jump test. So each different group is in different column and each cell represent the different participants' height that they jumped recorded in centimeter. So as you can see, there are 15 participants of each group. So what we need to do now is to perform a one-way ANOVA to determine if there is a significant difference between the average height measures of three groups. So the next step is to activate the analysis toolpack. So to install the toolpack, what we need to do is click the file button and click more, and you can see the option button, then click on add-ins, and in the bottom click go. So next is click the analysis toolpack and click the OK button. So now when you click the data, you should see the data analysis. Now we are ready to perform the one-way ANOVA. So to do this, click on data analysis button and select ANOVA single factor and click OK. So the first need to do is to input the range. So I will highlight all of my data. Next data, and next in the group by field, select the row or column that identifies the groups or treatment. So when you highlight the labels in the first row, when selecting the input range, then click this option. So in output options, there are three options. So first is the output range that lets you highlight the region. The next is the worksheet that can give you the sheet a name. The result placed in a completely separate Excel file is the third one. So I will select the second option, and name this as results. So here are the results of ANOVA. So in the first table, we can see that it is a summary of our data. So the first, basically there is a count, which is the number of participants of each group. The sum is just the total value if we're to add up all the value in each group. Next is the variance and the average. So let's now focus on the ANOVA result. The results here are put in three rows. The first row describes the results of between groups. The second row describes the results when the source of variation is within groups. And the last row is the total of the sum of square or SS and the degrees of freedom or DF. So since my p-value is greater than my alpha level of 0.05, therefore my hypothesis is no difference between the means of three groups. In other words, each group on average more or less perform the same of the vertical jump test. So reminder that one-way ANOVA test cannot tell you which groups are significantly different from one another. To investigate this further, you need to perform the post hoc test.
So, good day everyone. Today I will be discussing the steps in performing a two-way ANOVA. But before we perform the two-way ANOVA, let us first define what is a two-way ANOVA. A two-way ANOVA is a hypothesis test that allows you to compare group means. Like all hypothesis tests, two-way ANOVA uses sample data to infer the properties of an entire population. In this lesson, I have provided a step-by-step instruction for using Excel to perform two-factor ANOVA and then interpret the results. So I'll run through one example to explain the difference on the case where the interaction effect may or may not be significant. A botanist wants to know whether or not plant growth is influenced by sunlight exposure and watering frequency. She plants 40 seeds and lets them grow for 2 months under different conditions for sunlight exposure and watering frequency. After 2 months, she records the height of each plant. The results are shown here. On the table, we see that there were 5 plants grown under each combination of conditions. For example, there were 5 plants grown with daily watering and no sunlight, and their heights after 2 months were 4.8, 4.4, 3.2, 3.9, and 4.4 inches. So now we can use the following steps to perform a two-way ANOVA because we already have our data. First is to select the Data Analysis toolpath. On the Data tab, click the Data Analysis. If you don't see this as an option, you need to first load the free Data Analysis toolpath. Later, I will teach you how to install Data Analysis in your Excel. The second step is to choose an ANOVA. So here we will choose the two-factor with replication. In this context, replication refers to having multiple observations in each group. For example, there were multiple plants that were grown with no sunlight exposure and daily watering. If instead we only grew one plant under each combination of conditions, we would use without replication. But of course, our sample size would be much smaller. So the third step is to fill in the necessary values. The input range, the rows per sample, the alpha, and the output range. On the input range, we have selected the cell range which our data lies, including the headings. On the rows, since we have 5 plants in each sample, we have here 5. And on the alpha, we chose the significance level, which is 0.05. The output range is where we would like the output of the two ANOVA to appear. So we have chosen here SG and S4. So the last step is to interpret the output. Once we click OK, the output of the two-way ANOVA will appear. As you can see on the first 3 tables, it shows the summary statistic for each group. The 4.14 inches is the average height for plants that were watered daily but given no sunlight. And the 5.22 inches is the average height of plants that were watered weekly and given low sunlight. The average height of plants that were watered daily was 5.115 inches, and the average height of plants that were watered weekly was 5.15 inches. The 5.55 inches is the average height of plants that received high sunlight, and so on. And on the last table, it shows the result of a two-way ANOVA. So we can observe that the p-value for the interaction between watering frequency of sunlight exposure was 0.310898. This is not statistically significant at alpha level 0.05. The p-value for watering frequency was 0.9759 and 75. This is not statistically significant at the alpha level 0.05. And the p-value for sunlight exposure was 3.9e minus 8. So this is statistically significant at alpha level 0.05. So these results indicates that the sunlight exposure is the only factor that has a statistically significant effect on on plant height. And because there is no interaction effect, the effect of sunlight exposure is consistent across each level of watering frequency. That is, whether a plant is watered daily or weekly has no impact on how sunlight exposure affects a plant. So that ends my topic. I hope you have learned something from me. So thank you for listening and good morning.
So hi, I am Charifel Arlugu and I will be the one to discuss on how to interpret the key results for ANOVA. To determine whether the difference between group means are statistically significant, usually a significant level denoted as a alpha of 0.05 works well. A significance level of 0.05 indicates a 5% risk of concluding that a difference exists when there is no actual difference. For interpreting the results, you just have to look for the p-value. If the p-value is less than or equal to the significance level, you reject the null hypothesis and conclude that not all populations means are equal. If the p-value is greater than the significance level, you do not have enough evidence to reject the null hypothesis that the population means are all equal. Verify that your test has enough power to detect a difference that is practically significant.
Analysis of variance, or Anova for short, is a statistical tool used to compare the means of three or more groups or population. Anova is a widely used technique in many fields including biology, medicine, psychology, education, and business. In this discussion, we will focus on the application of Anova in different areas and its contribution to the field of biostatistics. In the field of biology and medicine, ANOVA is commonly used in experimental research to compare the means of multiple groups or treatments. For instance, in a clinical trial, a drug might be tested on a different groups of patients, and ANOVA can be used to analyze the differences in response between these groups. ANOVA can also be used in genetics to analyze the variance in phenotypic traits among different populations or individuals. In addition, ANOVA is used in ecology to compare the means of different species or population and determine their relationships. While in the field of psychology, ANOVA is used to analyze the differences between means of different experimental groups, such as the effectiveness of various therapies for psychological disorders or the differences in the performance of groups of individuals with different personality types. ANOVA is also used in education to compare the means of academic performance between different groups of students, such as the effectiveness of different teaching methods or curricula. In business and economics, ANOVA is used to compare the means of different groups of customers or products, such as the sales of performance of different brands or the effectiveness of different marketing strategies. The null hypothesis is that there is no significant difference between the means, while the alternative hypothesis is that there is a significant difference. ANOVA allows us to test the significance of the differences between the means and to determine which groups are significantly different from each other. ANOVA contributes to the field of biostatistics in several ways. Firstly, ANOVA allows researchers to analyze and compare multiple groups simultaneously, saving time and resources. Secondly, ANOVA allows researchers to make conclusions about the overall significance of the differences between groups rather than just comparing pairs of groups. Thirdly, ANOVA provides a framework for partitioning the total variance into different sources, such as between group variance and within group variance. This partitioning allows researchers to identify the sources of variability and to determine their relative importance. ANOVA is also used in biostatistics because it can be used to test the interaction between different factors. For example, in a clinical trial, ANOVA can be used to determine whether the effectiveness of a drug varies depending on the age, gender, or other characteristic of the patient. This type of analysis is known as factorial ANOVA and is used when there are multiple factors that may affect the outcome of the study.